Hello everyone. I want to overview Exadata database machine and efficient resource distribution between several databases on Exadata. First of all, I want to introduce myself. I'm Mari, Oracle Certified Master since 2016, and I'm a Senior Solutions Architect at FlashCreate. I have 9 years of experience in database administration and have been working totally for 12 companies during my career. I'm specialized with Oracle technologies and also Linux administration, and I am a blogger since 2010. I'm sharing my experience with Oracle and Linux on my blog. Recently, my blog has been entered in top 50 Oracle blogs, and my blog is dba010wordpress.com. Well, let's describe in a brief sentences what the Exadata is. It's a high performance and high availability for Oracle database workloads. It's a balanced hardware configuration, database server, storage server, InfiniBand switches, and there is one more Cisco switch. It's highly complementary with clustering and parallel operations. Oracle Real Application Clusters and the Oracle Partitioning are highly recommended software options. Database server, also called the database node, has 4 local drives with the size 600G and 10K RPMs. We can increase them up to 8 by removing the fillers and entering the new drives. We have 2 USB ports. We have a LED and power button. The first LED is a locator LED, which can be turned on by yourself, and you can find the server easily in a rack. The second one is the service LED, which can be amber in color, and if it is on, it means that the database server needs some service. Storage server, also called the storage node, has 12 archive disks with the speed 7.2K RPM. We have a USB ports here, we have a LEDs and power button also. We will discuss its hardware details in later chapters. Another core component of Exadata is InfiniBand switch, which has 36 InfiniBand ports, and the flash card, which is installed inside each cell server. We have database servers X72 and X78. Exadata storage servers are flash equipped. We have InfiniBand switches, we have Ethernet switch. The Exadata comes completely pre-cabled. You just need to plug in a power, connect to the network, run one command for rebuilding the Exadata, and you are ready to run the database. We have 2 types of database server options. We have 2-socket x86 server, 48 cores, and the memory can be increased up to 1.5 TB DDR4 dynamic RAM. 4-socket x86 server, 192 cores, and the memory can be increased up to 6 TB dynamic RAM. For internal network, we have 40 gigabit per second, and for public network, we have 25, 10, and 1G ports. External flash storage server has 51.2 TB NVMe flash, and high capacity storage server 25.6 TB NVMe flash, and also 120 TB SAS drives. And we have 2 socket servers. Totally we have 20 cores per server. We have 2 types of database servers, as I mentioned already. The first one I described in previous slides, and the second one is bigger in size. It has 2 systems, System A and System B, and it has 4 power suppliers. These are fans, and in the back there are 8 GPUs. X72 database server has Skylake CPUs, 224 core Intel Xeon processors, 2.1 GHz. Memory is 384 GB and expandable to 1.5 TB. But for that we must have 24 times 64 GB to be able to have 1.5 TB. Local drives, we have 4 and 600G in size, 10K RPM SAS drive. They are hot swappable and can be increased up to 8. We have this controller cache 2 GB, and we are not using batteries. We have during that time supercapacitor, which is better than batteries. It can charge and discharge quickly. So let's recall here what type of caches we have. We have write-through caching and we have write-back caching. With write-through caching, when the controller receives a write request from the host, it stores the data in the cache and writes the data to the disk drives. And just after that, it notifies the host that the write operation is complete. The process is called write-through caching because the data actually passes through and is stored in the memory during in its way to the disk drives. And during that time, you are 100% sure that data is on a disk. But with write-back caching, which improves response time to write requests by allowing the controller to declare the write operation complete as soon as the data reaches its cache memory. The controller performs the slower operation of writing the data to the disk drives at a later time. So, what about the network side? We have two 1G/10G ports and they are base twisted pair. They are LAN on motherboard based, and also we have SFP ports, 25 10G ports. We have PCI card slots here. This one is empty. This is an InfiniBand port, and we have ILOM port, serial port, USB port. We have 1G port here. LEDs are here. Power supply and fan are true. X78 also has Skylake CPUs, 824-core Intel Xeon processors, 2.7 GHz. The memory is 3 TB and can be increased up to 6 TB. Local drives are 6.4 TB in size, and they are hot pluggable. We have 8 InfiniBand ports, QDR 40 gigabit per second. They are PCI slots, and we can insert the modules here. We have InfiniBand ports here, as you can see. We have they are ports being card based, but we have also LOM based ports such as 1/10G port. 4 of them are here, another four are here. We have ILOM ports, we have serial ports, and we have power suppliers here. We have two types of storage servers, flash, external flash, and high capacity. X72 external flash storage server has Skylake CPUs, also two 10-core Intel Xeon processors, 192 GB memory, and the drives are 6.4 TB each, and they are NVMe flash drives. We have also two 150 GB drives for booting and rescue functions. No more USBs. In previous versions, we had a USB for booting. This was the first bootable drive, and it was located on the motherboard. If something wrong happened with the USB, you must shut down the cell server and change the USB and turn the cell on. In that case, we don't have a USB. We have two InfiniBand ports here, and we have ILOM, 1G, and serial ports. We have a USB port and LEDs, power supplier, and fans. We have a PCI card slots here. X72 storage server high capacity has two 10-core Intel Xeon processors, 192 GB memory. Drives are 12, each are 10 TB in size, and the speed is 7.2K RPM. They are SAS drives. We also have here 150 GB drives, 2 of them. They are used for boot and rescue functions. Flash drives are 6.4 TB, and this controller with a cache network is the same. We have InfiniBand ports, serial, ILOM, 1G port, and USB port, PCI card slots, and power supplier with a fan. As you can see, Exadata has 42 rack units. The database node X72 has only size 1 rack unit, and you have InfiniBand switches, 2 of them. You have Cisco switch. Cell server is 2 rack unit in size. You can have maximum 19 database servers and 18 storage servers. When you purchase the quarter rack, it comes with 2 database servers and 3 storage servers. X78 is 5 times bigger than the X72. Its size is 5 rack unit. You can have maximum 3 of them. 8 rack contains 2 servers, 48 cores, and 3 servers, 30 cores for a school of 4. And if you choose high capacity drives, you have such amount, and with external flash, you have such amount. When you purchase Exadata, it comes with quarter rack, and half of the resources are disabled if you want to have just 8 rack. For in case changing Exadata from 8 rack to quarter rack, you just need to remove the restriction for drives and for CPU cores, and you will have a quarter rack easily. With half rack and full rack, you have more CPUs, more database servers, and more storage servers. When you purchase a quarter rack, you add database servers. You can add up to 19 servers and up to 18 cell servers. Expansion rack summary is the following: that sometimes you may need more storage for on-disk backups, historical or archive data, file data, lobs, images, and for that you don't have to purchase another Exadata, which is quite expensive. You don't need to purchase compute nodes, you just purchase expansion rack and install the storage servers inside. Just keep in mind that with a quarter rack you have 2 InfiniBand switches, and with a full and half rack you have 3 InfiniBand switches. ACR Manager, which automatically creates service requests with Oracle support in case flash, memory, processor, or any hardware failure occurs. But it does not mean that your Exadata must be placed in the internet. It's unsecure, of course. For that purposes, you have one server where you install ACR Manager, and it will have an internet. And on Exadata side, you indicate the subscriber for traps, the IP address that was configured for ACR Manager. 9 key features of Exadata storage server software is Smart Scan, which means that most of the work is done on cell server. Hybrid columnar compression, which reduces the number of blocks for compressed data by dividing the data into columns instead of rows. And when having a columns compression, it means that the values will have the same data type, and there may be more duplication. That's why the compression is high. I/O Resource Manager, it prioritizes I/O bandwidth based on a database or workload within a database. Smart Flash Cache is located on a flash card and saves the data. And Flash Log, which saves the redo log information, so changes are set there. Storage Index eliminates unnecessary I/O by making some portions of describing the region on the disk that will have minimum and maximum value, and when you are searching something, you go to this portion, check your value to this minimum and maximum, and if it's not between of them, then you are skipping this region from reading. Exadata storage server security, for example, with database level security, you can restrict some grid disks to be seen by some databases only. And write-back cache, which is quite fast, which improves the write-intensive operations, because writing to the cache is faster than writing to the hard disks. If your application writes intensively, and if you find significant wait for free buffer weights or high I/O times, you should consider using write back cache. And adaptive scrubbing schedule, which is available on Exadata by its schedule. By default, it's every 2 weeks, and in normal systems, you just need to create the cron job for that, but Exadata does it for you. Oracle Virtual Machine Rack clusters can be configured on Exadata, and we have 2 slides about that. About IB networking, InfiniBand network isolation, by which you can control some of the virtual machines to access some cell storages. This is useful when you use PCI DSS compliance. Well, with normal databases, we have multi-tenancy, we have in-memory database, real application clusters, data guard, partitioning, advanced compression, advanced security, real application testing, Oracle special, and management packs. But with Exadata, you have more. The first one is offload SQL to storage, which means that the most of the work is done on a storage server. InfiniBand Fabric, which is 40 gigabit per second speed for internal connection. A Smart Flash Cache and Smart Flash Log. Columnar Flash Cache, which is something like an extension of in-memory database. It's saved in a flash cache in a columnar format. Hybrid columnar compression, I/O resource management, network resource management, and in-memory fault tolerance. Let's stop here and explain the in-memory fault tolerance. By indicating the in-memory clause for Oracle database tables or for partitions, materialized views, or columns, we can indicate also some another clause which is called duplicate, which will tell the Oracle to make some mirror on another instance, and in case one instance goes down, another instance will continue to work without rereading the data from the disk to the cache. And we have also an option to indicate all clause, which will duplicate the data in memory store between all the cluster nodes. And execution with direct-to-wire protocol means that the information about the global messages will be sent on a wire instead of going to the kernel and the network stack. It will go to the wire. It will use wire protocol, and it will save your CPU. This is Oracle parameter initialization parameter, which can be enabled on instance level, but database needs to be restarted, and each instance must have the same value. I/O resource manager. We have 2 types of database plans. Intra-database plan, when you are distributing the bandwidth between resource consumer groups inside the database, or we have inter-database resource plan, which divides the bandwidth between the databases. While hosting multiple databases on Exadata, there is a risk that one database may eat all of the shared resources and stop Exadata functionality. The shared resources are CPU, memory, and I/O. For distributing the CPU, this is not Exadata specific. It can be done on any server. We use instance caging. We set the CPU count parameter for partitioning the CPU between the databases, and after that we must enable resource manager to be able to make the above changes active. Otherwise, CPU count is not considered as a limit in case you do not set the resource manager, so it's mandatory here. We have 2 types of memory, SGA and PGA. It's recommended to leave 20% of memory for OS and other 80% distribute between SGA and PGA. So database usable memory in GB bytes is 80% of total memory, and this value is participating in another formulas. Sum of total HGMX size is a rounded function of 80% of database usable memory. And to avoid SGA swapping and slow performance, it's recommended to use huge pages and disable transparent huge pages. Transparent huge pages are dynamic huge pages that are dynamically allocated, so it's not good for databases and may cause the database not to reboot. To enable huge pages, we must set the parameter in sysctl file by the following formula, and we set the transparent huge pages never with a grabby command, and for each database we alter the parameter use large pages only and restart the total server. Recommended PGA size can be identified by the following formula. This is a 20% of database usable memory, but we have two types of PGA aggregate target, PGA aggregate limit, and the real limit is achieved by setting PGA aggregate limit. I/O resources can be limited using inter-database or intra-database plans using self-CLI command line interface. There are several ways to do that. I choose one of the following by setting DB performance profile to the value, and after the database needs to be restarted. We will use this value in the configuration in the rules that, for example, bank will have 70% of resources on the first level and the HRDB will have 30%. And the bank will take 100% that remains from the first level. So if HRDB does not use allocation of 30%, bank will use all the resources. The same can be done for the HRDB on the third level, and the fourth level is for other databases which are not having the performance profile set. We have four resource consumer groups: administrative, other reporting, and developers, and we can distribute the I/O between of them during the following way. Using the category plan, administrative will have 25% of allocation on the first level, and others will have 75%. On a second level, we have 100% of allocation for others, and on the third level, for reporting we have 10, and for developers we have 10. Thank you for your time, and the first one is my blog where you can see my experience and you can find very useful information there. The second one is my LinkedIn account, and you can write me through the emails and you can ask me any questions you have about the slides or any other Oracle related. So thank you so much and have a good luck.